Hello, everybody. Sorry about the inconvenience. All 14 of us, I think. Let's see. Ooh, 13 of us. Sorry about the inconvenience. I am home this week. I had a great spring break. In the fact that Wednesday, woke up with a cold. I mean, was my email not clear? I said, oh, cool, that's awesome, very exciting. Hello, everybody in the classroom. That's awesome. Good, I'm glad. I'm sorry about the inconvenience. I caught COVID over spring break, so I'll be remote. I will be there for the midterm. It's the first day I can come back to campus. Obviously masked, and I'll stay away from people, but it's just easier to manage midterm details from the classroom. So I will be there for the midterm, but review sessions will be remote. Got flashbacks to last spring with my Twitch stream, which is great. Okay, so it's 2:00. All of this is recorded, so we are just gonna go ahead and go. Before I jump to looking at MATLAB, does anybody have any specific questions that they want to ask about anything? I mean, I can answer questions about the midterm. I can answer questions about your homework. Does anybody have any questions they want to ask? I did put up some details about the midterm on UB Learns yesterday, I think. So if you go to UB Learns, a lot of it should be there. Under the midterm tab, there's various resources for you. Let me pull it up, remember. So there's all the review material in the review material folder. There's midterm instructions on what to expect. The survey, that's where you guys got the survey asking me what to focus on. You have practice exam with solved solutions and talking through the solutions and how you should approach problems in videos. I posted the homework solutions there as well. I will post the homework solution for number 7 on Wednesday morning. And then I also posted some information on where to go. So everybody has it on Thursday. For my students, you guys are going to be in Cook 121 and NSC 205. So last name A through O will be in Cook, P through Z will be in NSC. I tried to break it up by section, but that didn't work. It wasn't nicely going into different, whatever you call it, places. So what you should bring is your laptop charger. I'm gonna see if I can get my husband to loan me some power strips from our house. Cook 121, NSC 205. And then your student ID. Okay, so some questions. Is the difficulty level more on par with the practice exam or the homework? It's definitely more on par with the practice exam. That's why the practice exam is there. You're gonna have 6 smaller questions, just like the practice exam shows. The questions are focused on 2 or 3 topics at a time. So you might have a question that focuses on writing some input-output stuff and branching. So it's very small problems focused. Your solutions shouldn't need to be more than 10 lines of code total. So it's definitely more on par with the practice exam. Do you have to be in the classroom for the midterm? So you will be in the classroom. So make sure you show up to those locations for your midterm on Thursday. So you're not going to be able to access You're not going to be able to access anything other than MATLAB and UbiLearns and Zybooks. So it is essentially open notes, but we will be walking around and monitoring your screens to make sure you're not using Google or some other stuff. So bring your laptop to the exam. If you do have known charging issues with your laptop, or if you have limitations, let me know. Send me an email as soon as possible so we can start to mitigate some of those challenges sooner rather than later. You can use anything on UbiLearns. So in theory, cast homework solutions. You should also be able to use your homework solutions because you can open them up in MATLAB. And you can navigate through your file system in MATLAB. So you can use those if you want. Any other questions that I can answer right now? And I mean, we can answer questions again on Wednesday as well as we go through more of the information. Yep, Zybooks too. Zybooks as well. Okay, so keep asking the questions. I will answer them. I will go through review material today. On Wednesday, I will go over essentially my tips and tricks for taking the midterm. And I'll talk about how you should approach the midterm and taking those. But let's go ahead and jump into some material. Okay, so I looked at your guys' survey results. Those of you guys who filled out the survey asking what for me asking what I should cover. Thank you so much. I appreciate that. Overwhelmingly, most people said they wanted to focus on loops first, followed by logical indexing and then branching. So I'm definitely going to focus on 3 of those problems right now. We'll get through as many. You can see up here, hopefully this is big enough, but you can see up here I've got a bunch of different just examples that I put together this morning that we're going to go over between today and Wednesday. Like I said, the practice exam is a good indicator of what to expect on the exam, so please go over and do those for yourself as well and look at those video solutions. I created a bunch of videos. Last week, Tuesday. It's collectively created. I have looked at all the problems, I have touched all the problems, I have added in language, removed language, so they are fully approved by me, along with the other professors. But it's a collective between myself and the other professors. But I know what I tell you guys, and I try to be the best advocate that I can be for you guys when it comes to the assessments in this class, and that includes the midterm. So there is nothing on the exam that I haven't looked at and more or less approved. Okay, so let's look at this loops problem. So, so when we're talking about loops, we're talking about for loops, we're talking about while loops. Those are our 2 different kinds of loops. I do want to put in the caveat that loops is only covered in one problem on the exam. Just because it is relatively new material, you will see loops other places. But there's for loops and while loops that you might be exposed to on the exam. I put in these keywords, so whenever you approach a problem for the exam, you're looking at, okay, so what are some keywords? What are some constructs that I need to use for these problems? So some of the keywords that indicate loops would be repeat. So repeat something means you need to use a loop. Iterate through an array means you need to use a loop. While something occurs means you need to use a loop. For these values means you need to use a loop. If it says use a loop, you need to use a loop. If you see a capital sigma, that means you need to use a loop. So all of these are keywords indicating that you should have some sort of loop that shows up in your problem. From there, it depends on what kind of loop you want to use. If you have a specific set of numbers, so for loops would be for, this is recorded. So it was recorded, I will put it on my YouTube channel, I will put the link on UbiLearns. For loop, you would use this for a specified number of values. No one says you have to use a for loop. But if you know exactly what your values are going to be, a for loop is easier to use. A while loop would be, use this if you have a stopping condition. So, okay, so let's say we have this question. So it's not a fully formed question. All of the exam problems are much more fully formed, than even the practice exam problems. The midterm will also have 6 problems, yes. So here it says estimate the value of sine using the following series equation. So some of you guys haven't taken Calc 2, but we have seen the indication for sigma. So it's a series where n starts at 0 and goes to infinity. I can't put equations in MATLAB, so this is my version of the sigma equation. So it's a capital sigma, which is one of the things that we use as our keyword to know to use loops. So I'm going to use a loop for this one. It says n starts at 0 and goes to infinity. That's another indicator that I'm going to use a loop, where n is from 0 to infinity, where n is from 0 to 7, n is from 0 to some user-defined number. Indicates I'm going to use a loop. So for this one, it's not really specific on what to use for loop or while loop. I'm going to show it with both just to practice. But for a for loop, our syntax looks like this. For I equals, and then whatever values I want. 0 to capital N. We'll do 100. So let's say I want to do 100 and 1 iterations. So it starts at 0. So it's 101 iterations. But pay attention to what your values need to be. So in the problem statement, it'll be for, n goes from 0 to 100. That's what it would look like for this problem. It would be specific values given to you. But let's say it says for 0 to 100. Capital sigma is a summation. So I can go ahead and do sum equals sum plus. Remember, that's what we always see when it comes to these capital sigma problems. Sum equals sum plus a new term. That new term is this thing, calculated however many times. So in my equation, I have n. N is my I here. I can change I to n. Honestly, it doesn't matter what you name your variables. For the midterm, you're not really told what your variables need to be specified as. Come up with your own, as long as you know what your variables should be. So here, it's the values of n. So my new term is going to be this calculation. Obviously, it's not in proper MATLAB syntax. So here's my new calculation, but I need to go ahead and translate it from paper into MATLAB. So -1 raised to the I divided by 2 times I plus 1. This is factorial, which means I need my factorial function, times x raised to the 2 times I plus 1. I need an x value. In your midterm, you will be told explicitly what x should be. I'm going to calculate x as, pi divided by 5. Because I'm estimating the sine of x. Once again, your midterm will be much more specific. Also, keep in mind that that you get partial credit on your midterm. So if you're looking at your keywords and you say, okay, I need to use a loop for this problem, then just write a generic loop. Write for, and then start out with, okay, for and an end. I know I need a for, I know I need an end. It doesn't matter if your code runs. Your code doesn't need to run for the midterm, but you do need to show us that you know what constructs you're going to use at minimum, and how you might construct those even if it is incorrect. So for I is 0 to infinity. Calculate a new term, and then sum those terms together. That is the generic piece of a for loop. One thing you should know is how to print out inside of a loop as well, and I've shown you this many times. But if we are going to print out inside of a loop, you're going to most likely use fprintf, and you're going to print out all the valid values. So anything that might change. So I equals, figure out exactly how you want it to look. I equals insert a number. Then term equals insert a number. 0.4f. And then insert your sum. Followed by a new line. So I'm printing out I, I'm printing out new term, and I'm printing out my sum. So essentially what I'm saying is every single time I go through my loop, I want to print out the I value, I want to print out my term value, and I want to print out my sum value. You don't need to start with the 0.4, you just can start with the F, however you want to print it out. That's totally fine. Okay. That's what a for loop looks like. I'm gonna go ahead and run this code. For your midterm, if your code doesn't run, that's totally fine. Don't worry about it. And my code does not run. Not enough arguments. So sum. I did not sum, I sum at 0. There we go. So I have 100 iterations. You obviously will not be asked to print out 100 iterations. So let me change it to 10. There we go. So we can see how things change. So this might be a small problem that you might get on your midterm. There wouldn't be much more than this because we have to work in small chunks. But calculating for loop, calculating summation, maybe you would just be asked to just calculate your terms. Maybe you'd ask to just print out the sum. Maybe you'd also be asked to figure out an error. So maybe one more thing might be our error. Error equals absolute value of, I'm estimating the sine of x, so sine of x minus sum. Whoop, not bad. Ah, I know, I actually need to type an error. There we go. So we might be asked to add an error, but you can see more or less, this is how much code you might be asked to write for a single problem. This is what it looks like with a for loop. With a while loop, we would use a while loop if we're stopping with a specific condition. So I can go ahead and do the same thing, x equals pi over 5, sum equals 0. And then we'll say we'll stop when my error is less than 0 or less than a small number. So I'll start out my error as a large number. So while hold on, I'm reading the question. So Crazy Sniper, are you talking about notes in your solution files? Like you're writing your code and you're writing in notes and comments? Because you can write as many comments as you want in your files. You can write as many comments as you want in your files. In fact, the more comments, the better, because then we know what you are trying to do at minimum, that you understand the problem and you don't necessarily have the right syntax, or maybe you commented out some code that you know is causing an error and you haven't quite figured it out yet, but you still want to run your file. That's totally fine. Leave as many comments as you want in your files. You're not going to be penalized for more comments. If you are going to be graded on comments, it will say it explicitly in the document. So specifically for functions. For functions, you have your H1 line and your help text lines. You're going to be writing, I don't know, 2 or 3 functions for your midterm. If it says you need those comments, it means you'll be graded on them. If you don't need them, it'll tell you explicitly you do not need them. So, but yeah, so write as many comments as you need. So here I say while. I know I'm going to use a while loop for this one. So I'm saying while stop when the error is really small, which means continue while the error is really large. So this is an indicator to the grader that you know exactly how you're going to construct your while loop. It's also an indicator to you because you don't have paper. You're not going to have paper. Your midterm is going to be box links. So you're going to be assigned 6 problems randomly. So you're going to be linked to box files. I know it's not the most convenient, but that's how it's going to be. So you're not necessarily going to have paper that you're going to hand in, which is fine, but that means you don't have anything to write down on. So use comments in your file to go ahead and essentially make those notes that you know what you're talking about. And then if your code is incorrect, even though your comment is right, then that tells us that you know more or less what you're doing, you just didn't get a chance to fully debug it. Okay, so I'm gonna stop when the error is really small, which means continue when the error is large. So when my error is greater than some small number, 10e to the negative 10, or 1e to the negative 10, whatever that is. Stop when I have a small number. Okay. And then what am I doing? I'm doing these calculations again. Here we go. It's the same thing. Same thing. I don't have an I anymore. But I am starting out with my error at 1 so that I can go into my loop, calculating my new term, calculating the sum, calculating my new error. And then I can go ahead and print it out. And I have an infinite loop. Woohoo! Okay, so something went wrong with my loop, which is fine. That's not a problem. My error, notice over here my error never changes, which means I'm doing something wrong. Oh, I don't have I. That's why. My I never changes. I equals 0. And then I equals I plus 1. If you forgot I and you ran into an infinite loop, that's fine. You would get a couple points off. Maybe 1, maybe 2. I don't know. I'm developing the rubrics for the TAs tomorrow. But you get partial credit, so don't be overly concerned if your code is not working appropriately. Here we go. Here's my while loop terms. Here's my for loop, what it looks like. Here's my while loop. So we can see however many iterations I have, but this is what the difference might be if you're asked to write a for loop versus a while loop. For a specific set of numbers, while a specific condition is met. Okay, those are loops. For loop, while loop. Like I said, there's one problem with loops, so focus on the general structure. Don't stress over it if you're still struggling with the concepts. Focus on the structure. Write down all of the pieces that you know when it comes to designing a loop for a specific set of numbers. Repeating this code. While a specific condition is met, repeat this code. What are you repeating? Focus on that. Once again, this is how you print things out. So this will help you in terms of looking at how your values change over time. Okay, those are loops. Small problems. What is it? Each one? 10, maybe 11 lines of code. This is more on the scale of what your midterm problems look like. Okay, final questions on loops. Okay, let's move into logical indexing. So, logical indexing. I had that on there, and it's a separate problem. It's not really a separate problem, but it is a problem in your practice midterm. So I wanted to focus on it and see where you guys were at with logical indexing. Maybe some of you guys just didn't know what logical indexing is. I don't feel like, at least in one section with you guys, I definitely did not spend a lot of time on it in class because of that week of Monday's failure. But I did want to see where you guys were at, which most people were like, yes, we should do this 1 second. So I wanted to focus on logical indexing. Logical indexing, it's the idea that we can go ahead and index. So indexing is where you're grabbing specific values in an array. Grabbing specific, or a matrix, whatever it is. Array refers to a matrix, a vector, a scalar, all of those. So grabbing specific values in an array. In week three, we were grabbing specific rows and columns. With logical indexing, we can grab specific values based on some sort of condition. So rows and columns. We can also grab them based on a condition. This is our logical indexing. We can grab values based on a condition. And remember, the whole idea is we have two sides to our equal sign. So where do we want to put things? And what do we want to put there? So as you're going through your problems, if you ever run into a problem that says logical indexing, which keywords for logical indexing, do not use loops or branching. That is an indicator that you should use logical indexing instead. If you're asked to count values in a range, that means logical indexing. Count based on a condition. Grab values in a range. So grab values based on a condition. Grab values less than 25% the max, greater than 25% the max. Whatever that looks like, that's an indicator that we should use logical indexing. So don't use loops or branching, you should jump to logical indexing. Count values, jump to logical indexing. Grab values, jump to logical indexing. But here's the idea, where do we want to put things and what do we want to put there? So, like I said, there's a problem in the practice midterm. I wanted to review it here. One of the places where we can use logical indexing is to calculate the piecewise function. So let's say I have x values from negative 10 to 10. So x goes from negative 10 to 10, and I can go ahead and do a spacing, I don't know, 0.01. So I have a lot of x values. If I ran this code, I can go over my workspace and I can see that x values, there's 201. But either way, there's a lot of x values. And I want to go ahead and calculate y. But y depends on a condition of x. Y is going to be these values if x is between negative 10 and negative 3, these values if x is between negative 3 and 3, and these values if x is between 3 and 10. So if I think about where do I want to put things and what do I want to put there? Let's say y starts out as a bunch of zeros. So this syntax here, I don't know if you've seen this, but this is completely valid. Zeros, size of x. You could also do this in two separate pieces. So we could say L is the length of x. And I could say zeros, one row, length L. Wow, L is the worst variable to use. Len. We'll call it len. So len is the length of x, so I can go ahead and do zeros 1 to L. Another way you can do this is zeros size of x. This is also completely valid. But let's say I start y as a bunch of zeros. And you've seen this before. It's generally a good indicator to start a vector or a matrix as a bunch of zeros and then fill in the pieces that we need. Okay, so now I want to go ahead and fill in y. When x is negative 10 to negative 3, I want to go ahead and fill y with these values. There's a couple ways you can do this. We can say y. So y is the same size as x. So I'm going to say when y, I don't want to change all of y, I want to change part of y. The parts of y when x is greater than or equal to negative 10 and x is less than or equal to negative 3. So I'm changing y, part of y. Which part? The parts where x is greater than or equal to negative 10 and x is less or equal to negative 3. What do I want to set that equal to? What do I want to put there? My x values, such that it's 7 times x squared plus 3 times x. But it's not all of x, it's the x values where x is between negative 10 and negative 3. So this is one of the ways we can do this. One of the ways. Where do I want to put something? In y, where x is greater than or equal to negative 10 and x is less than or equal to negative 3. What do I want to put there? This equation where x is these values specifically. This is one of the many ways to do this. One of the many ways to do this. Keep in mind, anytime you do a calculation now, you should stop to think, am I doing this with scalars? Am I doing this with arrays? Do I want to use matrix math? Do I want to use element by element math? So first things first, am I using scalars or arrays? I'm using arrays. X is an array. Do I want to use matrix math or element by element math? I want to use element by element math. So I'm going to go ahead and put a period in front of every asterisk, caret, and division sign, which I only have asterisks. Okay. And I need single ampersands, otherwise MATLAB's going to yell at me. So I have a bad habit of putting in double ampersands. It's not a bad habit, it's just a habit. Okay. That's one of the ways to do it. Another way I can do it. I can go ahead and say that y1 equals these values. And then I can say y2 equals my second set of values. And y3 equals my third set of values. And then at the end, I can go ahead and concatenate things together. So y is going to be y1 next to y2 next to y3. Separated by commas because I want them to be placed next to each other. So there's multiple ways to do this problem. None of them are invalid. I could also do it in multiple steps. I could say, I could literally grab just the x values. I could say x1 equals the x values where x is greater than 10, negative 10, and x is less than negative 3. If you want to separate things out, by all means, do that. So here, this is completely within y itself. Here I have separate y calculations, and then concatenate things together. And here I can go ahead and grab separate x values. I can say x2 equals my second set of x values, x greater than negative 3 and x less than 3, and then x3. Then I can do my separate y calculations and then concatenate everything together. It really just depends on what you want to do. So if you run into a problem where you're asked to count some values, so counting values in a range. Counting means you're going to use sum these values. Grabbing values means you're going to do the array with your conditional. So here I'm grabbing the values, here I'm grabbing the values, so I have my original array. If I wanted to count the values, I would use sum. But that's your general syntax. So it really just depends on what you're asked to do. If you're asked to sum all of the values between, or count the number of values between negative 10 and negative 3, you would use the sum followed by whatever conditional. So sum all of the values, or count all the values in x, where x is between negative 10 and negative 3, you would say sum that conditional. If you want to grab the values, or if you're looking for the values in an array that are in that range, you would list out the name of the array followed by the conditional. Here's an example where you calculate a piecewise function. Multiple ways to do it. You can grab the values in y and change them explicitly. You can calculate your y values separately and then concatenate. So here are the y1 values, or the y values calculated where, using this calculation. Here's the values calculated with this one, and here's the values calculated with this one. Or you can separate out the x values. It depends on how many pieces you want to pull apart. If it helps you to pull things apart, that's totally fine. That is completely up to you. So here, if you leave comments, you should be able to indicate that, oh, okay, x1, these are the values in x between negative 10 and negative 3. If you're asked to concatenate values together, so if you're asked to essentially piece together y based on your separate y values, go ahead and write it out. Y equals the values from y1, or the values from x between negative 10 and negative 3, next to the values from x between negative 3 and 3. If you write in comments, if you're confused, especially if you're confused, if you're like, I don't know what to do, write in comments. What do you want y to contain? What are you trying to piece together? The values from this vector next to the values from this vector. Okay. So that's logical indexing. There's also another problem in your practice exam. So go look at that one. Look at the one from your homework, which is relatively similar to this one. Oh, did I mention I posted the solutions to the homework? Those are in the midterm review material. Yeah, I think I mentioned that. So go look at those solutions. They're all there. You can look at the ones for homework 6, which I'll be posting your grades for homework 6 probably after class is done. Use that as a reference. But that's logical indexing. In general, a logical indexing problem is typically combined with maybe some input. So maybe some function, or not function, but input output, like input or F for F or display. Or maybe array concatenation. So once again, write in some notes if you're lost and you're confused. There will be partial credit based on your comments as well, especially if you don't really know what you're doing or you don't know what to do. Just start writing down, okay, I know I need to create a new array. I would place these values here next to these values here. So use that as a reference, or that as a way to kind of fill in some of the gaps if you need some more ways to look at things, or are looking for points. As opposed to just like throwing formulas on the page. You don't have formulas, so throw comments in your files. Your midterm is going to be just files, so you're going to literally just submit your M files, so make sure everything is contained inside of your M files. Okay, next problem. So those are the top 2 ones that students wanted to review, and then it was branching, which makes sense. After branching, then it kind of got spread out a little bit more. But after those ones, it was branching. So, branching. We have 2 types of branching. We have if statements and switch statements. Keywords. If we know we need to use if statements, we're looking for the keywords if, choose, decide, determine. There are less keywords for branching. A lot of it really just has to do with, do you need to make a decision in your code? Do you need to decide between this option and this option? So it's not always necessarily clear whether or not you need to use a branching statement. If it says use a branching statement, use a branching statement. If it says use a switch statement, use a switch statement. So you should know generally the syntax for both. If it says use a switch statement and you use an if statement, once again, you get partial credit. So don't feel like you see the use a switch statement and you just completely blank on everything and you decide to go with an if statement, that the world is over. It's not the case. So you should know what the syntax is for both. You should be able to look up the syntax for both as well. So both of them should be values. So here is a problem. So I have a couple switch statement examples. I believe, yes, the practice exam has a switch statement. The practice exam is the same as the one before, but that is a switch statement. I'm going to focus more on if statements here. I will talk about switch statements as well. But here it says, given a number, determine if the number is positive, if the number is negative, even, odd, prime, integer, or non-integer. So I'm going to talk about different ways to figure out all this information for a number. The solutions to the practice exam are not explicitly posted, but the videos are there. There are video solutions. So use those as a reference. I mean, you can just go to the end if you're looking for the actual solution, but I did not post just the solutions. I suppose I can do that, but it won't be for a while. A while being probably tomorrow. But yeah, there are video solutions. Okay, so given a number, what is my number? Generally, it would be an input from the user. So these problems are typically included with input IO as well. And then I would need some sort of decision. I'm deciding between a positive number, a negative number, an even number, an odd number, a prime number, an integer, or a non-integer. So in your problem on your exam, it's going to be much more specific in terms of what is expected. But I'm going to go ahead and look at breaking this up into groups. So I'm going to first check if it's a positive number or a negative number. Okay, so if and I am deciding the number of options. So it might help if you're looking at number of options. There's 2 for this one, positive or negative. Okay, so if you have 2 options and you're using an if, then you have an if and an else. So if x or num is greater than or equal to 0, it is positive. Otherwise, it's negative. This is one of the ways you can do it. You could technically have an if and an else if. Num is less than 0. Notice, it's either this or this. There's nothing in between. So I don't need the else if, and I can just have an else. So there's multiple ways you can write an if statement. This is the most basic version if we're looking at a positive number or a negative number. It's one of 2 options. It's either positive or it's not positive. Okay, then I can go ahead and display. So display, when it comes to output in your, for your midterm, you might be told explicitly to use disp or fprintf. You might not be. If you're not told which one to use, pick whichever one you're more comfortable with. I like to use display if I am only printing out text or a single variable. I like to use fprintf if I'm combining them. It's really just up to you. If you're not told which one to use whichever one you want. Even if you are told which one to use and you use the other one, once again, it's not the end of the world because you get lots of partial credit. So display positive number. If you are using disp, you do not need to add in the \n. Okay, so here's what it looks like for a positive number and a negative number. So I can go ahead and run my code. Number 10, positive number. Run my code, negative 10, negative number. Once again, you don't necessarily need to run your code, but I'm just illustrating that it's working. Okay, that is my first if statement. Second if statement, determine if something is even or odd. If something is even numbers occur when when num divided by 2 equals round num divided by 2. Essentially, when I divide a number by 2, then it is a whole number. So here's my first one. So test equals num and divided by 2 equal to round num divided by 2. Okay, I'm going to do this separately just to illustrate different ways we can do things. Okay, so this is going to go ahead. This is going to be note equal sign. This is my conditional. My answer here is going to be 1 or 0. 1 if it's true, 0 is false. Which means it's going to be 1 if it's even and 0 if it's false. If odd. There we go. And 0 if odd. So I can go ahead and use an if statement. If I can just type this in directly. Otherwise it's odd. I can also do an else if and say that if it's not equal, then it's odd. Both of these are completely valid. Display even number. Display odd number. I can use fprintf for this as well. So let's say I needed to combine text and data. I can say fprintf. I want to insert my number. Insert 0.0f is an even number. That's what it might look like if I wanted to use fprintf. Once again, it just depends on what you have to print out. It depends on what you have to print out and whether or not you're combining numbers and not numbers, or combining data and text, whether or not you're just printing out text. It's up to you if you're not told explicitly which one to use. This is what it might look for display. This is what it might look for fprintf. Okay, so I'm going to go ahead and take this one out, run it. 10, it's a positive number, and 10 is an even number. Run it, -9. -9 is a negative number, and it's an odd number. In general, if you don't know what the conditional is supposed to look like, for your midterm exam, if it is something that's not really covered in class, we do give you guys a hint on how that conditional might be constructed. But if you don't know how to do it, use your comments. Say, if you have an even number, and then you can indicate an even number is when num divided by 2 equals round and num divided by 2. Maybe type in what is listed in the document. But this is what it looks like to do an even number. If I use test, I'll skip over that. Okay. I'm not going to go over switch statement syntax. Look at the practice exam, look at the previous problems that I've posted. In general, we're going to use a switch when we are comparing one variable to multiple options, to integer, or text options. And then an if statement, comparing anything else. If statements are generic ones. Okay, so I've done positive, negative, I've done even, odd. Let's do prime. So if a number is prime. There's really no generic formula to figure out if a number is prime, but there is a function. So you can go over to help and say prime or something. Prime not found is prime is a function. We're not going to ask you explicitly to use any functions you haven't used before or haven't seen before. But if you do want to use a function or are allowed to use another function, sometimes it might tell you you're not allowed to use anything else, then you can go ahead and look through the MATLAB help documentation. It's up to you on how you want to access that information. You can use MATLAB. You can type help, whatever the name of the function is. This function would determine if something is prime. So I can say if is prime, num, else, I'll just do that. This is going to be 1 for the elements of x that are prime and 0 otherwise. So if it is prime, I can go ahead and display prime number. So that's a general basic if statement, just one off. And then integer and non-integer. So if it's an integer, there also is a function called isInteger. It is not something you should use. It's talking about an integer data type. It's not talking about a numerical integer. So do not use isInteger if you are asked to determine if something is an integer. What you would do is you would say an integer occurs when the rounded number is the same as the original number. So just like I did up here. If num equals round num. That's how you can determine if something is an integer. So if that's the case, then you can go ahead and fprintf %0.0f is an integer. In theory, you should be able to use %d, but else, otherwise it's not an integer. fprintf .0f is not an integer. Okay. I can go ahead and run my code. 9. Positive number, odd number is an integer. 3.2. And yay. Okay, is prime is breaking my code, which is fine. I can just take it out. You're not going to be asked if something is prime. I just wanted to illustrate what it might look like if you might use a function that you haven't seen before, which may be valid. If you are told you can use anything else, if you're told you can't use anything else, then ignore it. There we go. Positive number. It's an odd number, apparently. And it's not an integer. Okay. So that's what if statements look like. You can have as many conditionals as you want. You could group all of this together and just do a bunch of else ifs. Doesn't really make sense for this problem. But the keywords, if, choose, determine, decide, it's not always explicitly noted that you need to use a branching statement, but if you're choosing between one of multiple options, make sure you're using a branching statement. Identify how many options you have, and you would write a conditional for all of those. You can have more complex conditionals. You might be able to check if a number is positive and even, if a number is positive and odd. So you can do those conditionals and num divided by 2 equals round num divided by 2. So this checks if it's positive and even. So your conditionals can get as complex as they need to be. So just pay attention to what your options are. Keep in mind what the syntax is for a switch statement. For a switch statement, you can have multiple options. So switch, and then what variable you're comparing all your options to. Case, you can have more than one option per case. So a variable is equal to option 1, option 2, option 3, option 4. That's your first set of cases. Your second set of cases, same idea, can be multiple options. Okay, so that's all we have. Time, how do you do the fancy, how do I do a comment on multiple lines? I type a comment in front of everything. Generally, I just type a comment in front of everything. Just type a bunch of comments. If you want to comment a whole bunch of stuff, you can always highlight it. And there is a comment button up here if you want to, where you can comment and uncomment if you want to do that. That is one thing you can do. But generally, I type a % sign in front. If you are typing something and it goes to the next line, if you have, I think, wrap text here, wrap comments clicked, it's up here, Control J, and you get to, there's this line here which indicates the end of the column. It will automatically go to the next line with a new comment. Okay, we are out of time. This is recorded. I will post it on UB Learns. There's other videos there. I will see you guys on Wednesday. Have a wonderful day, and I'll see you guys on Wednesday. If you want to stick around and ask me a couple questions, I will be happy to answer them. I'll sit here for about another minute, otherwise I will stop and move on to teach in the next hour. You have a great day too. Thank you for telling me to get better. I am feeling better. I just need to follow protocol. Oh, don't forget, homework is due tomorrow, not Wednesday.